Welcome to the Atsign Engineering Podcast. My name is Don Witt, and it is my privilege to be the host for the first Atsign Engineering Podcast. I'm also honored really to be an advisor going on 4 years now to the Atsign company and their revolutionary open source, totally secure AT protocol and supporting technology. What is Atsign Engineering Podcast about? With each episode, we will ask you to dive into the world of tech with us as we explore the best practices and innovative approaches. Whether you're a seasoned pro or just starting out, join our discussions and interviews to discover how to excel in engineering with Atsign style. Tune in for insights, tips, and the latest tech tips. Subscribe now and elevate your engineering game. Go to atsign.com. In this episode, Why or Why Not Kubernetes, the Atsign engineering team discusses Kubernetes. They will touch on some of the downfalls of Kubernetes, including failover and usage price. They will also explain why Atsign does not primarily use this technology. In addition, they will detail usage of Docker Swarm and why it was chosen over the other options. So let's go ahead and get started and introduce our panel of guests. And as I introduce you, can you give our listeners a little background of what you do with Atsign? Chris Swan, let's start off with you.
So, hey, I'm Chris Swan. I'm an engineer at Atsign for the past 3 years or so, based in the UK. And my focus is on predominantly the infrastructure side of things, though I also get involved in writing some of our SDKs and building demos of the technology.
Gary Casey.
Hey Don, so I'm Gary Casey. I've been with Atsign for just over 2.5 years, and I tried to make our software do what we say it does repeatably.
And last but not least, Colin Constable.
Hey folks, Colin Constable, one of the co-founders here at Atsign and the CTO, which means I'm normally out in the field meeting customers and prospects and then giving people like Chris and Gary hard problems to solve. It's a fun role. Yeah, it's been a really fun ride here at Atsign, at least almost 5 years now.
So why or why not Kubernetes? Chris, can you give our listeners a little overview of Kubernetes and let the others jump in as they need to?
Sure thing. So Kubernetes is an orchestration platform for containers, and it seems to have won out as the preeminent orchestration platform. So if I go back to sort of the early days of people using containers, and especially the sort of first DockerCon, which is where a lot of these things were announced, it felt like everybody had created an orchestration framework. So, Facebook had Tupperware. Docker announced their Docker Swarm. Google and Red Hat had worked together to do Kubernetes, which was sort of a baby Borg. So Borg being the way that Google manages containers internally. And then there was also things like Mesosphere. And so for a while, people were trying to figure out it's kind of, which one's going to be the winner? Where am I going to put my container workload? But here we are almost a decade later now, and Kubernetes has clearly won. And that's the one that almost everybody is using to orchestrate their containers.
When Atsign is in the process of making the decision on what to do, I think one of the first things that we needed to understand is what the Atsign needs are. Can you give us a little input on that, Colin?
Oh, yeah, 100%. So we actually did start with Kubernetes. I remember Christmas 2019, I was up to my eyes trying to learn how to get Kubernetes up and running. Essentially, each Atsign has its own personal data store, and that personal data store is run as a Docker container. So everybody has their own little Docker container, and you have to run up a Docker container for every Atsign. These are very small Docker containers. Back then, I think they were 5 megabytes in size, and that was about the smallest Docker container you could actually create and give that much memory to. However, as the more I learned about Docker and the more I learned about Kubernetes and pods in particular, we had this huge construct for a pod. and this little tiny Docker container, and you couldn't get very many pods running on a Kubernetes cluster. It was really good for one use case inside our infrastructure, which was our ad directory. So we still use Kubernetes actually for the ad directory today. It means we can just sort of let it get on with itself. But for the all of these personal data stores, these what we call ad servers, there had to be another way. We had to be able to access them, even if they failed. We didn't really care which machine they came up on, but they needed to come up. So you needed some sort of mechanism to expose ports and IP addresses. And I remember playing with Docker Swarm a few years back, and it just sort of fell into place. And it's been a really good choice so far. But I think when Chris joined, Chris, maybe you can talk to this, but I've always thought it's not perfect, and we could probably find something else, but we haven't found anything else so far to beat Docker Swarm for those things.
We haven't, and I think there's sort of two fundamental issues here. So fundamental issue number one is just about all orchestration frameworks are built for web workload. And that kind of assumes that you've got lots of requests coming into a web server, and when you've exhausted the capacity of that web server, then you just add some more capacity beside it and fan the requests out some more. And so Kubernetes is excellent at that. And that's why the pod construct sort of works for us for things like our registrar, and also isn't bad for something like the directory. But the second fundamental problem is every ad server needs to be individually addressable. And so, when we look up an ad server in the directory, we get back a fully qualified domain name and a port, and they're all different. And so that kind of ties to problem number one of it's not a web workload. It's something different. And most of the orchestration frameworks being designed for web workloads can't really cope with that. So Docker Swarm, it turned out, was able to deal with lots and lots of little things, and each of them being individually addressable. And that explains really why we've gone down that path. And we can talk as we go on about some of the refinements that we've made over time to optimize what we've got there. But I guess we could also talk about what we wish might be different, because I think it isn't perfect. And my greatest concern about Docker Swarm is it's sort of abandoned these days. It doesn't feel like there's been very much development on it for years.
So what did usage pricing have to do with it? It seems like one versus the other.
So Colin touched on this a little when he was talking about the size of pods. But the fundamental issue here is you want to optimize how you're using infrastructure. So you don't want to be wasting CPU cycles and memory, because things are often kind of constrained by memory and storage. And so when we look at having to have a pod for every ad server, then the overhead of the pod turns out to be about 10x the ad server. And so that implies that if we used Kubernetes, then it would cost us 10 times as much as using an alternative approach. If I look at, say, Docker Swarm, there isn't a pod concept, and so there is no pod overhead. And so it's quite capable of just deploying thousands of containers per cluster and dealing with that. So the management overhead there, we tend to provision 3 management nodes so we can stripe them across availability zones for robustness. And so that would be 3 managers to 18 of the worker nodes. And so that's giving us a sort of 1-to-6 ratio, which is pretty decent. If I think about how many Kubernetes pods I would get onto the same lump of infrastructure, I don't even think it would be 600. I think it would be more like...
I actually tried, Chris. It was about 250, and then things started going horribly wrong. And
yeah, there you go. So 250 rather than 6,000 is more than an order of magnitude.
Yeah. Pretty. I mean, it's not that it didn't work. It did work fine. It's just it didn't scale, which is a very odd thing to say. That saying that's seen as like the ultimate scaling infrastructure didn't scale in an environment. And to Chris's point, it's just because our workloads are just different.
But it's because it's designed for horizontal scaling rather than lots and lots of one. And so, we just don't fit into that typical sort of mold of the application pattern. And that's why, even though some other orchestration things have come along since from people like HashiCorp, they've also not been able to really fit with the workload pattern that we need.
So this is, where do we go from here? Because with Docker Swarm, it seems definitely that it's addressing the Atsign technology. And does it give it any special capabilities that you wouldn't have beyond the other options of Kubernetes?
So, can I jump in for a sec? I was just going to say, it depends. Yay, I got to say it depends. So it depends. It kind of depends what our biggest drivers are. So if our biggest drivers are, vertically scaling at servers for large customers, that'll drive us down one path. If our biggest driver is hundreds of millions of very small at servers for, tiny gadgets that aren't doing much, then that drives us down another path. And what we do with our overall architecture, is not set in stone. We have our architecture now, and we have the potential universe of architectures of the future. So, we're in this state now. We could be in a very different state 3 years from now. This isn't a we decided on this and this is the way it's going to be and that's the way it has to be, because of course everything is malleable over time, given enough time and money.
Maybe you can talk a little bit about this for us, Gary, but the architecture for the software isn't welded to the architecture of the infrastructure. And I think that gives us a little bit more leeway than maybe other projects.
Yes, very true. Yeah.
And could you explain sort of what those differences are for us, Gary? Because you're the software guy.
So there's a very long answer to that. I'll try and give a shortish answer. So, fundamentally, App Protocol is peer-to-peer. So that in itself, gives us a lot of flexibility in terms of how we can choose to architect our services and our infrastructure. Because when it's peer-to-peer, you have basically kind of the ultimate granularity, right? If you have, if your whole thing is predicated on very large multi-tenant, horizontally scalable things, then that does constrain the number of architectures and infrastructure architectures that you can choose. When everything is its own thing, you have a lot more choice. So I guess I'll stop there, Colin. I think that's the fundamental
Maybe that's
answer.
another show.
Yeah, I think that's the fundamental answer. We just have more choice. And the choices we make are driven by, our current drivers in terms of, where is there the most demand, and what are our biggest pain points, or what are our users' biggest pain points?
Yeah, so, it gives us the flexibility to go in both directions at the same time and still interoperate, right? So, very, very, very wide, hundreds of millions of ad servers, and also very, very large ad servers that are dealing with one very busy Atsign. So I don't know what we thought about that right at the beginning. It was a happy accident to like many good software decisions, right? So you sort of build on those happy accidents. But it is it is one of the joys of it being very, very distributed right from the beginning. I remember one of the conversations was within the first weeks, this has to run on a light bulb to a big cloud server. And that was sort of one of the 3 rules that we set out for ourselves. It has to be very, very small, but also be able to scale to very, very large. Can't hear you, Chris, for some reason. Sorry.
You're on mute.
To a certain extent, that running on a light bulb talks about the SDK, not the at server.
Yeah, for sure.
So you don't need to be able to run the service that the light bulb talks to on the light bulb itself.
Yeah, that was.
So I think as light bulbs become more powerful, that'll certainly become a possibility. But if we look at some of the challenges that we've faced and some of the challenges that we sort of still face with the orchestration, it's certainly not straightforward to run thousands of tiny little things. And so a snag we bumped into a few years back now was initially all of our worker nodes were Ubuntu. So we used Ubuntu for managers and we used Ubuntu for the workers. And we started having problems every time we were moving lots of workload around, which happened every time a node failed. So if say we had a few hundred Atsigns on a node and we were shutting it down to upgrade it, that would be a few hundred Atsigns trying to find homes on other nodes in the cluster. And that's what Swarm is there to do. It's there to kind of go, oh, okay, that workload is not running there anymore. We can put it somewhere else. But what we saw was, once there were a few hundred containers, and it's only containers that the operating system cared about, every time we added one or took one away, then Cloud Init on Ubuntu was just absolutely thrashing, because every time we added or removed a container, that was a networking change. And every networking change was something that Cloud Init was waking up and kind of going, oh, something changed on the system. I'd better run a whole bunch of scripts. And, we saw that things got very slow because Cloud Init was, again, it was about an order of magnitude thing.
Yep.
Cloud Init was using about 10x more resources than the containers themselves. And so we had to kind of get rid of Cloud Init, and we couldn't see a meaningful way to do that with the Ubuntu Cloud images, which are kind of built around Cloud Init. So we went to an alternative operating system for the worker nodes, and that's what took us to Flatcar. So Flatcar is the fork of CoreOS, which was one of the original designed for containers operating systems, where a lot of it is read-only file systems. And so it's predicated on the state management is happening inside of the containers rather than in the operating system itself. So no Cloud Init, no thrashing. And so we can now have hundreds of containers per node and pretty seamlessly move them around as we're dealing with failures or doing proactive stuff like upgrades.
Yeah, I mean, hats off for the Ubuntu team though, because load averages of 800 were unbelievable, and yet the machine would still answer because, I mean, Ubuntu and the rest of the kernel team had done a good job, I guess, but I'd never seen a load average of 800 when all those containers moving around. It was pretty shocking that it would even respond, but it did.
I think we even saw some load averages in the thousands, Colin.
It's just ridiculous, wasn't it?
Yeah, pretty insane. But then if I look at the kind of residual challenges that we have, it would be lovely to get much better insight into what's happening with the managers. So, what are the manager internals and how is it looking across the worker nodes and figuring out placement? And could we insert ourselves into that? So we talked a moment ago about bigger atsigns, busy atsigns. Are we going to have to deal with that manually, or can we start having policy in place which says, okay, we know that this is a big atsign, so put it somewhere where we've got a resource bubble around it, in order to better deal with that placement.
Now, when you're talking bigger atsign, are you talking more important or just size-wise?
So I sometimes talk about the Taylor Swift atsign. And just to be clear to listeners, Taylor Swift, to the best of my knowledge, doesn't yet have an atsign. But if Taylor Swift did have an atsign, then Taylor Swift would probably have millions of people wanting to keep an eye on applications that Taylor Swift would be using with her atsign. And so Gary and I quite often kind of have this speculative conversation of how do you deal with millions of connections? How do you deal with essentially the Ticketmaster problem of Taylor Swift said something and now the services are melting down. And so we've been doing a whole bunch of load testing recently to see, sort of what the limits are on our existing approach. But it's almost a sort of metaphorical thing that we use to talk about how are we going to handle scale.
Okay. Looking at the current architectures that are out there, different technology, like how different are we from, or Atsign from the others that are existing? I know it's a big question, but
so this is where we kind of come to the t-shirts we had printed with "Flip the Internet." I think the architecture's sufficiently different that in many cases it's the inverse of already understood architectures. And so, a lot of the web is about massively multi-tenant systems. And this is the opposite of that. This is massively single-tenant systems, or a massive array of single-tenant systems. And so a lot of the time we can benefit from all of the other work that's been done by the industry on how we write software and build and deploy software and make it secure and operate it at scale. But there are certain times where we kind of hit a bit of a bump where it's sort of, we're doing things the opposite way to how everybody expected things to be done. And so we have to figure out our own approach to doing that. One of the fun examples there is certificates. Every atsign has its own certificate. And so we are sometimes renewing an unfeasibly large number of certificates every day. And I talk to people who work for certificate companies, and they're kind of, okay, I can't think off the top of my head of other people that are renewing 2,000 certificates a day. But that's become such a normal part of our operations. And it probably deserves a podcast episode of its own. But we just get a report. How many did we do yesterday? How many failed, more than twice, more than 5 times, more than 10 times? And that's it. There's kind of no human involvement in that process at all now.
Moving forward, what are some of the goals that you would like to achieve with the technology?
That's another huge, big question. I think we all deserve a crack at that one. I imagine, so it depends, right, on which future, but I imagine a future in which pretty much everything has an @sign. Everything, every person, every organization, every division of an organization, every piece of software that's running as an atomic unit somewhere, could have an @sign. Could be tens of billions of them. in a world of tens or hundreds of billions of little microservices, what are the things you really want to be able to do? And one is, you need to be able to determine like what's the power law that governs the utilization of those at servers. Like, is it 90% are idle at any given point in time, or 95%? How long do they become active for? Typically, and what does that look like? And then building, this is a little dance of software and infrastructure implementation to figure out how do you minimize the amount of resource consumed in terms of CPU, memory, etc., across the fleet, without having it running too hot, and without it being overly wasteful. What's the Goldilocks place that allows you to make sure that you're running a little bit more than you need to, so that you can deal with ratcheting up and down, as up in this case, but you're not being overly wasteful, because and to take it to the extreme, if you have 100 billion at servers and only 1 billion of them are active right now, then you don't really want to be consuming 100 times more resource than you need to. Maybe twice as much is okay, right? But anyway, that's the thing that I tend to think about when I go wandering along the beach, is what sort of architectures will make that kind of thing possible. I could talk for a long time about this, but it'll mostly be ramblings, and that's not great for a podcast. So I'll pass over to Colin.
All right, so I'm going to talk about the far distant future when we've got rid of IPv4, which should have happened already, but still hasn't because of network address translation. But imagine a world where everything is addressable directly. And in that case, one of the things we had to do with our architecture is split, as Chris mentioned earlier, the client and the server. The server lives in the cloud, and the client lives on the device you're running on. Those things need to be welded together. And they can be welded together. We know exactly how to do it, but the infrastructure of the network, the internet, needs to be fundamentally the way it should be already, but clearly isn't. Everything IPv6, everything addressable, everything ready to protect itself. And I know for a fact Chris and I have been talking about that for the last 20 years, and we're still not there yet. So it's probably at least another 20 years away, which is fine, I guess. We're ready for it. But the joining of the ad client and the ad server sounds like a really fun opportunity. And Taylor Swift to have to carry around a very large cell phone, I guess, Chris. At least you need to decide whether you're going to be an ad server stroke client on your cell phone as it wanders around and has universal coverage across the whole planet, or whether you want to put that in a data center. So I'm way out there. I mean, 20 years away, but that's a sort of horizon you have to think about. And we've had many discussions and arguments about that, which is, I mean, those things are always a lot of fun to talk about. Yeah, Chris, over to you.
So I like to think about this in terms of orders of magnitude. So we presently run tens of thousands of Atsigns, and I think the containers-based approach easily gets us to millions, probably tens of millions, maybe even hundreds of millions. It does not get us to billions. It would just be economically ruinous to still be taking a container-based approach to do billions of Atsigns. And I think even as we kind of get into the millions or tens of millions, we'd probably leave the cloud and start using bare metal. So if we look at another company doing things with personal data services with Blue Sky, I closely follow their engineers and see that they're starting to use colo and bare metal for the heavy lifting in their personal data services. So what does billions look like? Well, I think it ends up looking a lot like object storage. And if we look at services like S3, I think Amazon's managing literally trillions of objects already. Now, when we talk about objects in object-oriented programming, we talk about objects having data and behavior. And when we talk about objects in object storage, it's just the data. Objects in object storage do not have behavior. But if we look at the behavior of an Atsign, then it's a very limited set of behaviors as defined by the verbs in the protocol. And so I think the billion scale infrastructure looks a lot like object storage, but with just a limited set of behaviors layered on top of the data, so that people can interact with that. And then back to Colin's point about where does this actually live? Well, you then get into sort of interplanetary file system type considerations of, well, it can be as close to the device as you want it, and actually things like phones have got a huge surplus of compute storage and memory these days for many of the applications that they're running. So why not have it there? But the Taylor Swift problem will remain, and I don't think anybody will be making a phone big enough, and certainly the network won't cope with that. So this is where I think a concept that we've known as intelligent agents for a long time will come into play. And so part of that intelligence is actually in the infrastructure management that Taylor Swift's agent, her Atsign, is in a place where the millions of people that want to interact with it can get to it, and that can handle that load.
I'll ask each of you if you have any last comments before we close out for the first episode. Gary, do you have anything to talk to our listeners about?
Nothing more than we've said already. I just find that it's endlessly fascinating, this world, and there's a whole. I think we're at the early stages of a wave, in the world, which is about massively peer-to-peer, decentralized, everything addressable, no central point of control, all this stuff. We're still in the very early stages of that. I think it's going to be fundamental for the future. Like, again, if you look at 10 or 20 years and beyond, and it's just really fun to be, at a company that's participating in the very early stages of this. So, yeah.
Chris, do you have any last comments?
It may seem to people from the title of this podcast that we're here to have a go at Kubernetes, and that's not the case. We use Kubernetes where it fits the bill, but we just happen to have a workload that doesn't fit Kubernetes very well, and so that's forced us into using an alternative approach, and that in turn makes us try and do some other things differently.
Yeah. I have actually dreamt up an architecture that would use Kubernetes for @servers if we had a slightly different implementation of @servers for the for some of those for some of that spectrum of @server, probably up to the 50th percentile. A Kubernetes architecture could actually work really well. So yeah, Kubernetes. It's all about horses for courses. What is the best horse to pick to ride the particular course?
Colin, any last words?
We're very lucky here at Atsign that we can have infrastructure engineers, application developers, architects and Imagineers, all in the same place, arguing together and trying to solve things and making sure that everything's as flexible as possible and as forward-thinking as possible. I encourage anybody listening to, if you're in a little silo, like I used to be in a large enterprise, break out the silo. Those guys across the hallway are not that scary. They're trying to struggle with the same problems as you are. So if you don't think Kubernetes is being forced upon you, and you don't think your workload fits Kubernetes, then hopefully you enjoyed this, and you've got enough courage to go over and say, hey, maybe there's another way. And I think you'll find the infrastructure people are like, well, tell me more. And maybe you'll find out you're ending up with a slightly different infrastructure. But yeah, continue arguing, continue debating. Nothing's set in stone in our infrastructure, as you've probably heard. We're always looking for the next thing and the best thing to make sure we've got a flexible platform for everybody to use.
Based on the goal of Atsign, it's clear that the needs that Atsign had were totally identified and have been addressed, quite frankly. And they don't really coincide with the current architecture that's out there, but in another way, that's really a good thing, because I think what's been constructed is revolutionary. And congratulations to everybody here. So for those listeners, we want to have you go ahead and subscribe. We're going to have some more outstanding episodes that are innovative engineering approaches for Atsign, and hopefully for your organization as well in the future. So thank you. Go to atsign.com and subscribe. And to those that are here, Gary Casey, Chris Swan, Colin Constable, thank you for your time today. And we'll talk to our listeners the next time with the next episode. Thank you.